Hello everyone, this is Lakshman Panda. I am representing from Mechanical Department. Today I am going to share a lecture video about fluid mechanics. So what is fluid mechanics? Fluid mechanics is a branch of engineering in which we study about behavior of fluids. So first of all we should know what is fluid. Fluid means, in short we can say, it is combination. It is either a liquid or a gas. So if a particle is a liquid or gas, that can be called as fluid. So we will go through the syllabus of acidity. So in fluid mechanics there are 7 sub-chapters. Okay, so we should understand what is the main things that is consisting in syllabus. So in first chapter we will study about properties of fluid, in which we will study many properties like density, specific weight, and viscosity, surface tension, specific volume. So there are number of properties that is present in a fluid. So we will deeply understand each property in this particular chapter. Then in second chapter, fluid pressure and measurement, we will study what is fluid pressure. Then there are so many types of pressure: absolute pressure, gauge pressure, atmospheric, and vacuum pressure. So there is a graph, and on that graph which lines are which corresponding pressure we will understand from this chapter. Then next there are so many measurement device also, that is manometer and mechanical gauge, and manometer is also classified in so many types, and mechanical gauge is also classified in so many types. So we will study some of the measuring devices, pressure measuring devices in this chapter. Then in third chapter, hydrostatics. In this chapter we will study when a body is submerged in a liquid, or when a solid body is submerged in a liquid, whether it is submerged vertically or horizontally or in an inclined manner. So when it is submerged in different ways, in that situation we will find out the total pressure, okay, total pressure or center of pressure of that particular force. Then next is in this chapter also we will study Archimedes principle, then metacentric height, concept of rotation, and so many other concepts in this chapter. Then fourth chapter, kinematics of flow. In this chapter we will study if there is a fluid which is already flowing, then definitely there is a quantity of that flow. Okay, so in this chapter we will study types of fluid flow. Okay, the flow which occurs, flow which is done by the fluid, we will understand in this chapter the types of fluid flow. So there are so many types: steady and unsteady, and laminar and turbulent, compressible and incompressible, one dimensional, two dimensional, three dimensional. So many classifications of fluid flow we will study in this chapter, kinematics of flow, and so many other points are also consisting in this chapter, that Bernoulli's theorem, our continuity equation. Then one machine called venturimeter, which calculates the flow, means our rate of flow, which calculates our rate of flow or discharge. Okay, so this is fourth chapter. Then fifth chapter, orifice, notch and waves. So the person who studied venturimeter in kinematics of flow, orifice meter is a similar part of that, but it is included in fifth chapter separately. And then notch and wear, we will, when go through this chapter, then deeply understand what is notch, what is wear, and what are the discharge calculation formulas. Then next is flow through pipe. Flow through pipe. In this chapter we will study what are the energy losses, okay, how the energy losses occur. Then so many lines are there, so many gradient lines, we will study about that also, and so many laws also. Okay, there is so many laws to calculate that energy loss, because when a fluid is flowing through the pipe, so many energy losses occur. So to calculate those energy losses, we will study some laws like Chayes' formula, etc. from this chapter. Then impact of jet. So impact of jet, okay, there are also so many categories in which impact of jet means impact of a water area is striking to a vane. Then we will calculate the force applied by the vane, and etc. in this chapter. So there are also inclined, vertical, so many types of cases in this particular activity, and under that 6 derivations are available, which we will study in 7th chapter. So overall we understood what is the syllabus. When we will study one by one chapters during classes, then we can understand this particular introduction video. Maybe from 2nd chapter to 7th chapter, so many things are new for us. Okay, so maybe currently we are not understanding that, but when we go through the classes on day-to-day basis, we will understand one by one. So I am again just recalling it. So first chapter is particularly about properties of fluid. Second chapter is about fluid pressure, means how to calculate the pressure, and so many pressure measuring devices are available to calculate that pressure. We will study about that. Third chapter is when a body is submerged in a liquid. On that case, how we can calculate the total pressure force. Okay, so that we will study here, and so many laws are available, Archimedes principle, and so many other principles are available. Then 4th chapter, so about it is in one word we can say it is about the rate of flow or discharge. Okay, 4th chapter is about rate of flow or discharge. Then orifice, notch and wear. So one term is available, one machine is available, that is venturimeter and orifice meter. These two machines are used to calculate the rate of flow in a pipe. So venturimeter section is included in 4th chapter and orifice meter is included in 5th chapter. Then notch and wear we will discuss during the classes. Then flow through pipe. Flow through pipe we can study that energy losses and corresponding loss to calculate the energy loss, etc., etc. Then impact of jets. In impact of jets we can study when a fluid is a set of fluid, a area of fluid is striking one point, then what is the force applied by that impact by the jet. So we will study, and 6 derivations are available, and we will study about that. So currently, after a good overview of the syllabus, I am going to little bit touch the introduction part. Okay, then I will also touch the main themes of next chapters.
So
first chapter is about properties of fluid. Okay, so there are so many properties like density, specific weight, specific volume, and specific gravity, viscosity, surface tension. So there are so many important properties that we need to understand in this chapter. First of all, density. Density is a property of fluid which comprises of formula mass by volume. The formula of density is mass by volume, and we all know from chapter mechanics that mass is the quantity of matter stored in the body. So the quantity of matter stored in the body per its volume is called density. So in short we can call it density, but the formula is mass per volume. Then specific weight. Its formula is weight per volume. So weight is the multiplication of mass and acceleration due to gravity, because generally we don't see weight as a mass or weight. Okay, weight is actually force. Okay, weight is a force experienced due to gravitational acceleration, but generally we day-to-day life we speak the unit of weight as kilogram or gram, but actually the weight is the unit used kg or gram, that is actually symbolizes to kg force, which is the unit of weight, actual unit of weight, but we speak it as kilogram or gram. That is not the actual unit of weight. Actual unit of weight is kilogram force. So kgf is equal to 9.81 Newton. Okay. So when we tell density is equal to mass by volume, specific weight is equal to weight by volume, we should clearly understand the difference between mass and weight. Mass is the quantity of matter stored in the body, weight is the force experienced due to gravitational acceleration. So weight is equal to mass multiplied by acceleration due to gravity. Then specific volume. Specific volume, its formula is volume by mass. Then specific gravity, its formula is density of fluid divided by density of standard fluid. Density of fluid divided by density of standard fluid. So what do you understand? What do you understand from standard fluid and fluid? Fluid is any type of fluid which we take as a consideration in the particular example which comes under practice. But standard fluid is the general fluid. Means if we are using a liquid here, then standard fluid is water. If we generally use air here or any gas here, then standard fluid is dry air. So according to that, we can use the formula of specific gravity, and similarly, likewise we use density of fluid by density of standard fluid. You can also use specific weight by specific weight also, which is already present on the notes and books. Then viscosity. It is the property of fluid in which one layer of fluid, okay, flows with respect to another layer of fluid. Okay, this is one of the property. In short, we can say it is the friction. Like we say friction in solid body, we can say viscosity in fluid body, because due to this property only, one layer of fluid flows over another adjacent layer of fluid. Okay, so its mathematical formula is tau by du by dt. This is the mathematical formula of viscosity. Then surface tension. Surface tension is a property, is a tensile force acting on the surface of the water. Okay, this is a tensile force acting on the surface of the water. So its formula is, we can say, force per unit length, okay, and symbol is sigma. So in first chapter, probably we have understood so many things. We will, if go deeply, then we should understand what is the unit of each and every property. Okay, what is the unit of viscosity, and under viscosity also kinematic viscosity, we have to understand what is kinematic viscosity, Newton's law of viscosity, and after that also so many other things are also need to be understood, like capillary, okay, what are the types of fluid, so many points are available that we will study deep.